In this video, we're going to use Venn diagrams so that we can visualize sets geometrically or using a visual picture to see what's going on with the sets. And also, they also help us to count the number of elements that are in the set using the picture. So to set up a Venn diagram, we begin by drawing an outer rectangle. Okay, so this represents the universal set U. And then we're going to draw a circle for each set. Okay, so if you're in set S, you're going to be inside the circle, and if you're outside, if you're in S complement, say, then you're going to be outside the circle. Okay, so you can first visualize the sets by shading. Okay, so let's say in this first example, I have the universal set U, and then I just have one set S. Okay, which represents this circle. And it wants me to shade the region or regions that correspond to S complement. Okay, so obviously if I'm in S complement, so we want to shade the part where the elements in S complement would be. So they're going to be in the universe, but outside of S. So it's going to be all of the area outside of set S. So this would be S complement. Okay, so slightly harder. Now I have over here the universal set with two sets, S and T. Okay, so this is circle S and this is circle T. And I want to shade S intersect T. Okay, so S intersect T is elements in both S and T. Okay, so for the shading, that's going to be where these circles overlap. So it's just going to be this region here. Okay, now if we go down to the next one, what about S union T? So this is elements in S or T or both, right? Because it's the union. Okay, so that means when you're doing these shadings, so often people find the union harder, but it should actually be easier because you want to take anything that's in S. So we can start by shading everything in S. Okay, we don't have to worry about overlap here or overcounting because basically everything that's in the union is in S or T or both. So I want to shade everything in S and also shade everything in T. And that's going to represent the union, S union T. Okay, slightly more challenging one. Maybe I'll switch back to yellow. So here, I want elements, okay, so in S complement and in T. Okay, so that means they're not in S and they're in T. Okay, so in T means that they have to be in this circle, okay, and it's an and. It's an intersection. So that means both things have to be true. So they have to be in T and not in S. So in T means that they're in this circle. Not in S means that they're in the outside of this circle. So that's just going to be this region here. Okay, so this region is in T and it's not in the S circle. So that represents S complement intersect T. Okay, now there's some laws you can use for complements that I can show you, or show one of you. I'll show one of them using a picture. So if you want S union T all complement, that is S complement intersect T complement. Okay, so you switch the sign and you complement each thing. Okay, similarly, S intersect T all complement is S complement union T complement. Okay, so these are what they call De Morgan's laws. Okay, now let's just show one of them. I'm going to call it proof in quotations. because it's not really a proof, because I'm just going to use a picture. Okay, so let's do this one. So we'll do, okay, that one here. So S intersect T complement equals S complement union T complement. Okay, so I'm going to try and illustrate this using a picture. Okay. Okay, so here's the S circle, here's the T circle in my universe. So here I'm going to shade S intersect T complement. Okay. So let's do that. Let's do it in green. So it's the complement of the intersection. So the intersection is just this part. So the complement is going to be everything else. Okay, so everything outside of that middle bit is going to be in this complement set. Okay, so that's what it would look, that's our shaded region. Okay, now I want to show that the other side, so S complement union T complement, has the same shaded region. Okay, and I'm going to do that by doing two pictures and then unioning them together. Okay, so I'll make these pictures a bit smaller maybe. Okay, so here's my two pictures. Here's S, here's T, S and T. So in the first picture, I'm going to have S complement, and in the second one, I'm going to have T complement. And then putting them together, we're going to get one diagram down here. Okay, so this one is going to be S complement union T complement. Okay, so for S complement, it's everything outside of S. Okay, so that's going to be everything outside of this S circle. Okay, T complement is going to be everything outside of the T circle. Okay, so it looks like that. And then when you union two diagrams together, you just shade everything that's shaded, right? Because if I'm a union, it's everything in here, or both. Okay, so we shade everything. So you could, if you want to do it in, I'm going to do it in the different colors. So I would shade everything in S complement. Okay, but then I also shade everything in T complement. So then you can see the only bit that we didn't shade is that middle bit. So what it ends up being is everything that was shaded. I'm just going to shade it again in pink. So it ends up being all of that. So that's how you do the shading. Now it looks different because they're all different colors, but it should be all the same. Maybe if I shade this one again, it will get darker. Now I'm just making it worse. Well, okay, I unshaded a lot here, so I'm going to unshade. Whoops. I didn't like the way it looked. So let's just reshade it again. Okay, so I'm going to reshade it in pink like I did. So it ended up, so we shaded everything in S complement. So everything outside of S. But then we also shade everything outside of T, which ends up adding in this little bit here. And we get that. And then we can see, oops, that these have the same diagram. Okay, which means they have the same elements. So that's sort of proof by picture. Now, we can actually use these to help us solve counting problems as well. So you could also solve these without using a Venn diagram, okay? But then you have to use some of the formulas and maybe some complex formulas that I haven't even given you, but that you could figure out. Okay, so the Venn diagram is a useful way to display the information. Okay, so once we get into some examples, you'll see. But yeah, you don't need to use them, but I think it's very helpful, and most people I find tend to like them. So what we want to do is notice that when we have a Venn diagram, it divides the universal set into a bunch of regions. Okay, so I gave you some examples here. So here's a 2-circle one, and here's a 3-circle one. So if we consider each bit as its own region, for the 2-circle one, I end up getting 1, 2, 3, 4 regions. And for the 3-circle one, I get 1, 2, 3, 4, 5, 6, 7, and 8 regions. Okay, so that's what I said. When you have 1 circle, you just get 2 regions. 2 circles, you get 4 regions. 3 circles, 8 regions. Okay, it's always 2 to the power, the number of circles, actually, which we'll find out when we get into counting a bit more. So each of these regions is called a basic region. So instead of shading these regions, we can instead mark how many objects are in them. Okay, so knowing the number of objects in a basic region can help us determine the number of objects in more complicated sets that we can find by joining together basic regions. Okay, so let's just see an example, how we might do this. So, suppose we have a kindergarten class of 25 students, and we know that 20 students like chocolate chip cookies, 15 students like oatmeal raisin, and 12 like both. Okay, so I'm going to just define some notation first. Okay, so my universal set is the set of kids in the class. Okay, and I'm going to let's call it set C, be the set of kids in the class that like chocolate chip cookies. Okay, and I'm going to I don't want to use O because O looks like a circle, so I'm going to use R for the kids in the class that like the oatmeal raisin cookies. Okay, so then I know, so what I'm given is I know the number in the universe is 25. The number in the C set is 20. The number in the R set is 15, and the number in C intersect R, so the ones that like both, is 12. Okay, and I can use this to make a Venn diagram. So my Venn diagram is going to have 2 circles because I have 2 sets. Okay, so I have the C circle and the R circle, and I have the 4 regions. Now there's one region that I know exactly how many students are in, okay, and that is the intersection. So the intersection here, C intersect R, is one basic region, right? It's this region right here. Everything else corresponds to more than one region. So the number in C, that's the number in this whole circle. So that's 2 different basic regions, okay? So what I can do is I can put the 12. I know there's 12 students in the middle. Okay, that's because of that yellow thing. Okay, now I know that the C circle has to add to 20 So the remaining space has to be 20 minus 12, or 8 students. Okay, so because of this, that's how I get that number there. Okay, so that 20 corresponds to the 12 that like oatmeal raisin as well, and the 8 that don't. Okay, so similarly, there's 15 students in total that like oatmeal raisin, but 12 of them like both. So that means that 3 of them like only oatmeal raisin. So they don't also like chocolate chip. And then I can do the outside. So I know that everything has to add to 25. So the outside should be 25 minus 8 minus 12 minus 3. So that's going to be 2. Okay, so that comes from there. And so now I know exactly how many students are in each basic region. And now I can answer anything about this set of students. So how many students like at least one type of cookie? So that's going to be the number. Oops. So at least one means that they like chocolate chip or oatmeal raisin or both. So that's the union. Okay, so that's going to be a union. And the union, so we could, if you think about what the union set would be shaded, we would shade all of C and then all of R. So I could add those 3 numbers together. So this is 8 plus 12 plus 3. So that's going to be 23. Okay, now you could have done with this without the Venn diagram if you use the principle of inclusion-exclusion, and it would be the number in C plus the number in R minus the number in the intersection, which would be 20 plus 15 minus 12, which again is 23. Okay, so this one we could easily have done either with formula or with the Venn diagram. Okay, now this one is a bit harder because how many students like exactly one of the 2 cookies? Okay, so that means that they don't like both. So it's not an or both, it's an exclusive or. So this is going to be the number that like chocolate chip and don't like oatmeal raisin, plus the number that don't like chocolate chip but do like oatmeal raisin. Okay, so that's how you can write it in sets. So then from the diagram, we can see, I'm just going to match the colors. So this one is the green basic region, and this one is the pink basic region. So this is going to be 8 plus 3, or 11. Okay, so let me just write, so like chocolate chip, not oatmeal raisin. And these guys don't like chocolate chip, but do like oatmeal raisin. Okay, so that's just this basic region here and this basic region here. So that's why I know I just need to add those 2 numbers up. So there's 11 that like only one type of cookie. Okay, let's try a bit harder one. So this one has 3 sets. Okay, so again, I'm going to summarize the information. Okay, so the number in the universe, that's the number of countries with flags. So that's going to be 194. 145 flags have red on them, so I'm going to call that set R for red. So that's 145. 132 have white, so we'll call that W. So that's 132. And 104 have blue, so that's a B, and it's 104. And then we also know 103 have both red and white. So the number in red and white is 103. 66 have red and blue, so red intersect blue is 66. 73 have white and blue. Okay, and 53 have all three colors. So that's red and white and blue is 52. Okay, so that's what they gave us. Now, normally when they give you this information, they normally give it most generally and then they get more specific. So when you're filling in the diagram, you often want to go the opposite way because we want to start with the most specific stuff and then get to the more general stuff. Okay, so I'm going to make my Venn diagram. And I need three circles this time. Okay, so this is red, white, and blue. Okay, so again, we want to, so we divide into 8 regions. The only region that we know for sure is this middle region. Okay, so there's 52 flags with all 3. Okay, so that number is going to be 52. Now for these intersections, it doesn't say, so when it says they have red and white, it doesn't say that they don't have blue. It doesn't say anything about blue. So that means that we don't know about blue. They may or may not have blue. So this intersection, red intersect white, is 103, means that these 2 spots have to add to 103 because that's where red and white intersect, right? Would be this shaded bit. Okay, so that means that this spot up here has to be 103 minus the 52 we already know have both, and that's going to be 51. Okay, similarly, red and blue is 66. So this is going to be 66 minus 52, or 14. Okay, white and blue is 73, and then I subtract the 52, so that's going to be 21. Okay, so now we know each of those, and now we can start filling in the last bit. So the number in red is 145. So that means everything in this circle has to add to 145, which means the remaining spot has to be 145 minus the other spots. Okay, so if you minus those, I think you get 28. Okay, on the white side, there was 132, but we want to subtract all the other ones that we already know. Okay, so if we do that, we get 8 in that region. And then there's 104 with blue. 14 of those have red on them and not white. 52 have both red and white. And 21 have white but not red, which leaves 23 that have blue on them but not red or white. Okay, which is that space there. Okay, now finally, the outside space, we know there's 194 in total. And then if I subtract everything that's inside, I should get what's outside. So these would be the flags that have none of red, white, or blue. Okay, so that's 28 minus 51 minus 8 minus 14 minus 52 minus 21 minus 23. And if you do all of that, I think you get 3 on the outside. Okay, so when you're doing these Venn diagrams, you always, always, always need to start in the middle and work your way out. Okay, so these spots are the second most closest to the middle. And then you can do these spots and then the spot up here, unless they give you some spot exactly. So sometimes they will give you weird spots, and then you can put those in exactly. But normally, well, you're hoping they give you the middle because everything sort of depends on the middle. So now that we have that filled in, how many flags have at least one of the 3 colors? So at least one means that they could have red and white, red and blue, red and white and blue, etc. That's the union. So what we're looking for here is red, union white, union blue. So you could add up everything in the circles, right? That would be this whole shaded region. So you could add up everything there, or we can be clever and take the total 194 and subtract the ones that don't have any using the complement rule. And we get 191. Okay, but you could also add up all the other numbers. Okay, this is the same as if you did 28 plus 51 plus 8 plus 14 plus 52 plus 21 plus 23. You get the same number. Okay, how many flags have white but not red or blue? So that means we want the number that have white and don't have red, so we're in red complement, and they don't have blue, so they're in blue complement. Okay, this is a basic region. Okay, so this set is just the region here. Right? They have white, but they don't have red or blue. So they're in the white circle, but they're not in the red circle, and they're not in the blue circle. So this, now that I have it all like that, is just 8. Okay, it's just one basic region. Okay, now the next one is similar, except it doesn't say anything about white. So they have red, but they don't have blue. So that's the number with red and not blue, so B complement. Okay, so this is going to be more than one basic region. Let me just pick a color here. I can use green. Okay, so for this one, so they're in red, but they're not in blue, but they may or may not be in white. Okay, so they're in red, but they're not in blue. That's going to be these two here. Okay, so for this one, all we have to do is 28 plus 51. Which is 79. Okay, now this is the number that's in red and not blue and not white. And these are the ones that have white on them. Okay, the notation isn't so important, but I'm just trying to get you used to it. Okay, now this one is hard to write with notation. Not as one set anyway. So exactly 2 of the 3 colors. So that means that I want the number that have red and blue but don't have white, plus the number that have red and white but not blue, plus the number that have white and blue but not red. Okay, so those are going to be the 3 middles. Not middles, but these 3. So they have exactly 2 of the colors, means they're in exactly 2 of the circles. Okay, so red and blue and not white, that one is the 14. Red and white and not blue, that one is the 51. And white and blue, but not red, is the 21. And if you add those together, you get 86 in total. Okay, so once you have it listed, like set up in the Venn diagram, it's really easy to answer all different types of questions about this data. This part B we could have done with the principle of inclusion exclusion again for 3 sets, but the rest of them would have been harder to do with formulas. Okay, but with the Venn diagram, it's fairly straightforward.